Okay, today we're going to look at Chapter 2, Lesson 3, which is found on pages 58 to 61 in your textbook. Today we're going to be looking at writing an expression for the missing value in the table. So we're basically trying to find out what's going on in the table, what's the rule that applies to every number in that table. So for here we have Spike's age and Rusty's age. We see that the numbers are increasing from 2 to 6, 3 to 7, 4 to 8, and then A to something we don't know. We're trying to figure out what's going on. So if I can plug any number into A, I know what to do with that to get Rusty's age. So from 2 to 6, that's increasing. We know when we increase numbers, we're either adding to them or we're multiplying. So let's see, 2 plus something is 6. And sometimes you're just going to do guess and check and see if that works, and if it doesn't, you just come up with something different and see if that works. So if we have 2 plus 4, does that equal 6? Yes. Can I say 3 plus 4 is 7? Yes. 4 plus 4 is 8? Yes. These all work. So therefore, I see my rule is whatever Spike's age is, we add 4. So if I have A plus 4 is going to give us whatever Rusty's age is. So if I were to plug in 35, if I say A equals 35, I can plug it into my formula. A plus 4 equals Rusty's age. So if I'm using 35 for A, 35 plus 4 gives us 39. So if Spike is 35, then Rusty's 39. And now we're also going to looking at a table that is going from position to value. So we're going from top to bottom to see what's going on. What's the pattern or the rule or the thing that's going on that's the same from the top position to the value of the term. So, okay, let's do check and guess again. We have 1 times 3 is 3, yes. We have 2 times 3 is not 5. So that doesn't work. Okay, so we can't do that. That's not going to work for all of the things in our table. Let's try something else. Okay, we did times, let's do plus. 1 plus 2 is 3, yes. 2 plus 2 is not 5, so that's not going to work either. Okay, I've done my multiplication, I've done my addition for a single step problem, and neither of those work, but I do see my numbers are increasing. So that tells me that I have a multi-step problem. So now I need to be a little more creative in coming up with something that's going on with these numbers to get that answer. So, okay, what can I do to get from 1 to 3 that's multi-step? Okay, let's see. Maybe I can do 1 times 2 is 2 plus 1 would give me 3. Okay, that would work. If I plug 2 into this spot, if this is our position and this is our rule, then this should be our value. So 2 times 2 plus 1 is 2 times 2 is 4 plus 1 is 5. So yes, that would work for that particular position. 3, can I put 3 in the place of this number over here, the position? 3, and keep the rule the same, times 2 plus 1. 3 times 2 is 6 plus 1 is 7. Yes, that worked there. Let's try the next one. You got to keep trying other ones on your table, not just 2 or 3, because it may work for 2 or 3, but not the rest of them. So let's try 4. 4 times 2 plus 1 equals, 4 times 2 is 8 plus 1 is 9. Yes, that works. 5. 5 times 2 plus 1 equals 11. Yes, that works. So what's my rule? Whatever I put in this position, n, I'm going to do times 2 plus 1. So that is my expression that I'm going to use if I were to put 58 in the place of n, or 2005 in the place of n, or any other number. Whatever n is, I'm going to do times 2 plus 1 to get the value of the term. Okay, tomorrow in class we will be working more on this skill and looking at some additional tables.